Our general context is the phenomenon of climate change, and in particular, the role that carbon dioxide in the atmosphere plays in that phenomenon. Now, chemists these days can very easily analyse carbon dioxide concentrations in the atmosphere, and we know from measurements that before the Industrial Revolution, the concentration of carbon dioxide was about 270 parts per million, and now about 420 parts per million. That's molecules of carbon dioxide per million molecules total, mainly nitrogen and oxygen. Which leads us to the question, is it even feasible? Is it remotely possible that such a low concentration, such a small number of carbon dioxide molecules amongst many other molecules can actually affect the climate of Earth, affect the properties of the atmosphere, which in turn affects the climate of Earth? Augie. Prof, when you asked that question yesterday, I went away and Googled about climate change, and I came across two websites, both of which poked fun at the idea that such a low concentration of carbon dioxide molecules, 400 in every million, could possibly have any effect. They said it was ludicrous to think that that could be significant. Well, Augie, it seems very likely to me that you've stumbled across a couple of websites, and there are many, in which the producers are what we call climate change deniers. People who are mocking the possibility that carbon dioxide at such low concentrations can have an effect, not because they're thinking rationally or scientifically, because they don't want to be involved in any attempts to minimise the effect of climate change because it might affect the amount of money in their pocket. Let me suggest, if you can identify who they are, you might take a drink and meet them and have a toast. I've got here a solution of strychnine. Very dilute, 0.01%. It's only one molecule of strychnine, one strychnine molecule in every 10,000 molecules of water. Very dilute. Perhaps suggest that they might want to drink some of this because it's very low concentration. You'll have to try a couple of mouthfuls yourself, Aussie. Just a couple. Very low concentration. No. Yeah, well, no. Neither would I. Well, let's have a look at something a little more relevant, a little more closely aligned to our problem. I have two samples of water, about 500 mils each. And I have two food colours that I bought in the supermarket yesterday. One red, one brown, one blue. I'm going to add just one drop of the red one into this sample of water. Try and get just one drop. Might have been two. Wow. Quite an effect, wouldn't you say? I think what's happened, we're seeing red, quite a high intensity of red. And this, molecules of this stuff, absorb photons that are green and blue from the white light coming through and only transmit the red photons, and we see red. Even a very low concentration is absorbing enough of the blue and green photons to have considerable effect on the properties of this solution. And if I do similar to blue, with the blue food colouring, look at that. Now, two things here. One is that only a very, very low concentration of these molecules is now absorbing red and yellow photons and transmitting blue ones, and even a very low concentration can have a very considerable effect. And the other message from this is that molecules of different substances absorb very specifically different wavelengths of the white light that's incident upon them. So it is possible that very low concentrations can affect the properties of either water or of air. This situation, in fact, is the same as, it's analogous to it corresponds with carbon dioxide's role in the atmosphere. This particular solution is absorbing red light, photons of red light, photons of yellow light. The only distinction, the only difference between that and carbon dioxide's role in climate change is that the carbon dioxide is absorbing photons of infrared radiation. And that's where we're going. Now, don't forget, not only can very, very low concentrations affect the photons, the amount of photons being absorbed, but if you remember, Beer's law is not only the concentration, but the path length. How far through the medium does the radiation travel? And in the case of carbon dioxide and atmosphere, we've got photons of infrared radiation coming from Earth across a path length of perhaps 20 kilometres, even if it's decreasing atmospheric pressures, 20 kilometres. And in that time, we're talking about the possibility that photons of infrared radiation are absorbed by a carbon dioxide molecule on its pathway to what would otherwise be on its way to outer space. So, I haven't proven that carbon dioxide at low concentrations is having an effect, but I think I've demonstrated that low concentrations of particular molecules can have an effect in fluid mediums. So when you're sitting around the dinner table or sitting with some mates and someone comes up with the idea that, hey, it's such a low concentration, Pffft, can't do anything, you've now got something more than just an opinion to fall back on to defend the view. So foreshadowing, where we're going now is, does a change of carbon dioxide affect the energy balance of the Earth? And if it does, I'm going to suggest to you that it does. How does it do that? Why does it do that? See you soon.